In this lesson, we're going to go through and do a little bit of analysis on the impact of web application vulnerabilities. Now, as we do this, we're going to take a look at a sample e-commerce website. That's going to involve a web front end and a database backend. So we're first going to assess the database functionality. Then we're going to look at the website functionality. After that, we're going to test some injection vulnerabilities and then test some authentication vulnerabilities. First, I need to test my database and my web server. So to do this, I need to make sure they're running. So I'm going to type in service, MySQL start, and hit enter. Then I'm going to type in service, Apache 2, start, and hit enter. This is going to start both the database server and the web server on my staging environment. Now from here, I'm going to open up the database administration using Firefox. To do this, I'll type in Firefox, http://localhost/phpMyAdmin, and then enter. At this point, Firefox will load up and I'll be brought to the login screen for phpMyAdmin. This is a web front end to interact with the backend database. From here, we'll be able to look at the tables inside the database and even run SQL queries. So all I'm going to do here is log in. Now that I'm in the backend, I can click on devtech_store, which is the database that I want to look at. In here, you can see there is new, categories, products, and users. And under categories, products, and users, those are my different tables. If I click on categories, I can see here the different rows that I'm going to have inside that table. Essentially, inside this table is a list of different product categories. Inside the ID column, that's going to be our primary key, and then the name column is going to list the name of each of the different product categories. There are a total of 9 different categories here. Notice you can see the SQL statement at the top. It says select star from categories. That is what we're doing here. We're selecting everything from the categories table. Next, let's select the products table and review that data. Again, this is another table and it lists all of the different products. Instead of looking at the categories, we're looking at the individual products here though. Each product has its own product code, description, price, and whether or not it's going to be in stock and what category it belongs to. If we go and look at the users table, we can look at that data. Inside of here, we have a list of all the users who can sign into our website. Each user has a username, a password, a first name, a last name, and a level of permission. Now notice one major vulnerability here. We are storing our usernames and passwords in plain text. So if you look in the password column, you can see each person's password. This is a very dangerous practice. Instead, those passwords should have been hashed, and then the hash should have been stored inside the database. Now look at the URL that's used to access this data. Notice it calls sql.php, and that's a script that we're going to use. It's a PHP script. Now, when it does this, it actually gives you parameters from the database. This is going to be something like the database, the table, and the position within the table. So if we look under the SQL statement again here, we can click the edit link. And from here, we can change this SQL statement to say whatever we want. For example, if I want to see who has admin permissions, I can type in select star from users where permissions equals admin. And this will actually return just one record for us. This website is going to go into that database using scripting languages like PHP to pass those SQL statements in a secure way so the user can't inject additional parameters. Now, as we see this phpMyAdmin, this is an admin tool. This is not where our users are going to be inputting data. Instead, they're going to do it from the website. So let's go ahead and take a look at the website itself. First, we're going to open the browser and go to http://devtech, which is a sample e-commerce website here inside my lab environment. Now, this is the website for the store, and it's running on my local Apache web server that I started up at the beginning of this video. If you select the catalog tab, you're going to be able to see all the products inside the monitors category. They're all listed here from a table. Note that the URL here that's used to serve this web page, it doesn't have that SQL query anymore. Instead, it says catalog.php:/category equals 1, which is selecting the first category, which was monitors. Now, there are better ways of doing this, and this isn't necessarily the most secure way or the least secure way. It's just one way of doing things. Now here, we're actually passing in a parameter directly by saying category equals 1. That means if this was something that was behind a secure paywall, for instance, we wouldn't want to do this because somebody could easily change that 1 to a 2, and that would select a different category directly. Next, I want to go ahead and try testing injection vulnerabilities. To do this, I'm going to put the website on the right side of my screen and the phpMyAdmin on the left side of my screen. Now from here, what we're going to do is we're going to verify the URL that's passing the parameters. In this case, category equals n. In this case, it was category equals 1, to make sure that we're viewing the right category. So what I'm going to do is I'm actually going to go to the insertion point at the end of the URL, and I'm going to add a space. And then I'm going to type or 1 equals 1, which, as you remember from our lessons, 1 equals 1 is a very common way of doing an SQL injection. Now, once we do this, we're going to see what happens. Notice here that the listing page still says we're in the monitors category, but we're not seeing just monitors. We're seeing every single product that this company has. That's because we just injected this or 1 equals 1, making every statement true and not just to display category 1. This is a basic SQL injection. Now notice in the SQL query section, we can verify the query that we executed based on the URL we inserted from the web page. Notice that the query is selecting 4 columns from the products table. Anytime it finds the product category is N, in our case 1, or where 1 equals 1. And because 1 equals 1 every single time, guess what? It's going to dump every single category all at once to the screen. Now that we've tested injection vulnerabilities, let's go ahead and test an authentication vulnerability. We're going to go into the Sign In tab, and we're going to attempt to sign in as Kevin. Now, when we try to sign in, if we don't know his password, we're going to get an error, and it's not going to let us sign in. Now, we don't have the ability to crack his password at this point, so instead, let's try an SQL injection. Now here, we're going to put Kevin as the username and try to put something in the password field to cause a malicious SQL statement to be formed. This is an SQL injection. So, if I do something like X and then a quote, space or, space quote, X quote equals quote X, that will be able to do an SQL injection for us because the quote is going to break apart from that password and then test the second half of the statement, or something equals something. And so let's see how this looks. Now, to see what I actually typed in, we're going to go and right-click on the field and do Inspect Element. This will allow us to see what was there inside of the field. In HTML, when it's a password field, it's going to show up with stars or dots instead of the text. So I'm going to change that password field to text, and that will allow us to see what I actually put in. So now we'll go ahead and click on the Sign In button, and you'll see that it sends that to the MySQL database, and we get back an error inside the database giving us a warning saying that there was a parameter of 1 to be expected, but instead we got the results of /var/www/devtech_store/html/signin.php on line 37. Essentially, we caused an error in the program by doing this injection, but we were still able to successfully sign in. Now notice we are logged in, but we're not logged in as Kevin. It says welcome, space, period. It doesn't say welcome Kevin. Why is that? Well, because our malicious query took advantage of the default apostrophe formatting, and because there was no sanitized input, because they didn't do input validation, I was able to do an SQL injection. By doing that, it's going to go and look for the first authentication in the table. In our case, that first person is actually going to be Laura Anderson, and that's the person who has administrative privileges. So we are now logged in as Laura Anderson, the database administrator. So you can see how powerful SQL injections can be and how easy they are to conduct when somebody doesn't do the right protections on their website, either on the front end using input validation through the website, or on the back end when they don't have things configured quite right. It's not your job to figure out how to fix all these things, but it is your job to figure out if they're vulnerable to these types of attacks. And so you need to understand what an SQL injection is, and usually when you see something like 1 equals 1 or X equals X, that's a dead giveaway. Now on the exam, if you're asked how to fix something like this, the best answer is going to be input validation. If they had done input validation on the website and took away my ability to insert that apostrophe, it would have prevented this SQL injection from occurring in the first place.